So good morning and welcome to this session about Microsoft and AI. So I'm going to provide you with a random walk around the Microsoft AI research agenda. And in order to start, I'm going first to mention what we have done so far. So our strategy around AI is very simple. Our goal is to amplify human ingenuity, which means that basically we want to democratize AI. So AI has gone through a lot of transformation, a lot of winters, and AI is now back through big compute, powerful algorithms, and massive data. Even if, and I will go back to that, it's also possible to do AI without massive data. So at the end of the day, AI innovation is what has been motivating us since a while. We have today about 7,000 engineers working in the field of AI every day. So that's a very important field for us. If you look at what has been done through the most recent years, it has been first to get some breakthroughs in vision. So you perhaps know the ImageNet benchmark and the ResNet algorithm we have been implemented through deep learning. With 152 layers, we have been able to beat everybody on this benchmark with 96% accuracy. Then, last year, we have been able to accomplish some breakthroughs in speech recognition on the switchboard benchmark with 4.1 error rate on the switchboard benchmark. We have also been able to accomplish some breakthroughs in language, especially in language recognition, which are now in operational mode through Skype Translator as an example. So those are the major breakthroughs we have been able to accomplish. But at the end of the day, our goal is to bring AI to every developer, whatever platform they are going to use. Which means that we will embrace cloud, but also edge in such an environment through an integrated AI stack, which is this picture here, but I'm not going to explain everything. What is very important in this slide is the fact that we are relying on a global infrastructure made of CPU, GPUs, but also FPGAs and potentially ASICs. And we also are able to support every framework, scikit-learn, which was described just right before this morning, but also CNTK, our own framework, TensorFlow, and other libraries. The goal is really to welcome every developer on our platform, whatever the tool they are currently using. Within this stack, we are supporting conversational AI through speech recognition and bots, which means that we have been able to partner with Stack Overflow as an example to help developers to write code. So you are able to go through this bot, ask questions, and potentially get the code you want to do, the task you want to accomplish. We have also implemented a very comprehensive set of cognitive services which are able to cope with a lot of various fields of AIs, like vision, speech, language, knowledge, search, and a various set of labs, knowing that the goal is to offer those services through REST APIs, which means that you are able to call those APIs to do the job you want. If you want to use it, this is the website from which you will be able to start, knowing that what we have been able to accomplish is going to be exemplified in this video which is a very good example of democratizing AI.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind. And that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do. But artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
This is what for us means democratizing AI. This application is available on the Apple Store, so you can download it if you want. And it could be useful for everybody, not just if you are blind. I'm going now to talk more about what we are doing as far as research in AI. So if you look at the major fields which have been defined in the 50s around AI, those were perception, learning, reasoning, and natural language. And this is how everything started at that time. Then a lot of new fields or subfields appeared with their separate researchers and potential separate fields. So within Microsoft Research, until very recently, we also had a lot of different research teams working on those different domains without knowing them very well and potentially doing their research in silos. So we took the decision to move everybody in the same place, not really the same place because there are several places in the world, but the goal is to have one leader for all this research and also to make sure that everybody is trying to help the others in their various research fields. If you look at what are our major key aspirations as far as research is concerned, we can try to define those through three main pillars. First, attain more general intelligence. Two, master human-AI collaboration. And three, provide insights on AI, people, and society. If you look at the first one, so general AI is a very trending topic today, even if we believe that general AI is a little bit further ahead from what we are still able to do today. So in order to get there, we think that it is very important to create what we call integrative intelligence, where we took narrow intelligence, narrow AI, and we try to make sure that those different AI are able to collaborate. The goal being to combine competencies into symphonies of intelligence. And we also need to understand better the main principles of more general AI. So if you look at in a little bit more detail what we try to accomplish, we certainly try to deeply understand core AI competencies covering machine perception, learning, planning, decision-making, natural language, and all that, knowing that the goal is to bring those set of capabilities together into richer and more general intelligences. So our goal is to explore through various scenarios integrative approaches to bring together those different skills. So in order to reach this goal, we need at least to address 4 key main challenges. First, we need to be able to do what a 2 years or less child is able to accomplish, which is to understand the world in a very unsupervised manner, knowing that you don't have too much data as a child. Your mother or your father is able to explain to you what a cat is, and you don't need to have thousands and thousands of cat images in order to understand what a cat is. You are able to generalize very spontaneously. You are able also to understand what law of physics are, like gravity as an example. You know that if you drop your toy, it will fall, which is a very complex thing to explain to any computer today. We also need to embrace common sense reasoning, which means that you are able to understand better the world with which you interact and also what common sense is. You need to embark some key set of social and emotional skills which are currently being used by humans and not so frequently by computers. And basically, then, this is what I was describing about describing the surrounding physical world. It's very important to give those skills to AI. The second key aspiration is around master human-AI collaboration. The goal is basically to augment and extend human capabilities. If you look at the human intellect and its abilities, there are a lot of blind spots, biases, gaps in this environment. And the goal is to use AI in order to complement and potentially help those gaps to be fixed. So the goal is to leverage and extend results from the cognitive psychology, which was a field which was of a deep interest at the end of 1990s and which has been mostly abandoned in the recent days and years. So the goal is to go a little bit deeper in this environment by helping us about memory, attention, and judgment as a few examples. So in order to do so and to augment our ability via machine intelligence, we need to be able to better understand through a better understanding of computing and cognitive psychology around problem solving, notably, and also to better understand how it is possible to design for a mix of initiatives between human cognition and machine intelligence through machine learning and inferences. So inference is a very important topic. The fact that we are able to understand people intention, people needs based on their histories, activities, and the content they generate is a very important and key topic. So we believe that achieving deep human-computer symbiosis is difficult but very promising field of AI. The last pillar is about insights on AI, people, and society. So the goal here is to embrace a lot of dimensions around trustworthiness and safety, fairness and accuracy, transparency and explanation, and to explore human and AI relationship. So I will go a little bit deeper on that a little bit later. I want now to talk a little bit randomly about a few in-progress topics on which we are currently working. The first one is around data scarcity. So we all believe that we have a lot of data, which is true, but there are a lot of cases where, unfortunately, the amount of data available is not so huge. And at the same time, there are cases where the amount of data is so important that you cannot use AI on very small machines, on very small devices. So in order to go there, we are working a lot on transfer learning, learn from rich simulations, and learn from generative models like GAN as an example. So I'm going to just cover one topic on this, which is how to potentially embed deep transfer learning into very small devices like Raspberry Pi. So the approach we took is to use the ImageNet benchmark, where we learned from 1 million photos, and we decide to cut the top, if you look at the inputs at the bottom and the outputs at the top. We took the approach to cut some layers in order to generate an output feature vector. And we try to go a little bit deeper by using our knife to cut a little bit more. And using these output features, we used a very easy method like K nearest neighbors in order to be able to classify and recognize photos as an example. So we use KNN in order to do this clustering at the end of this deep neural net model. And the goal was to basically embed all this in this very small device around a Raspberry Pi and a camera. So here is what's that. We take some photos, 4 in fact. The goal being to be able to, it has been a little bit accelerated as you can see. So this was the training set. Then we do facial recognition. The goal being to embed this facial recognition into doorbell cameras as an example. So in most of the cases, we are able to get very precise results in this environment. So that was a first example of using transfer to learn from a very small set of data. I've also talked about generative models. The goal is to generalize from minimal training sets, as was mentioning, and also to harness physics. And I'm just going to cover how to harness physics in a deep learning pipeline like you see here. So here we break the deep neural net pipeline, and we embed some graphics in the middle of it in order to better understand what is the posture, what is the light, what is the shape. And the goal is to be able to potentially recognize the same face in different positions. And it is very efficient, and the goal is to be able to disentangle and generalize when you use a face in various conditions of light and potentially shape and positions and posture. So I'm going to mention and to give you a few words about AI infrastructure. So today, AI is mostly based around GPUs and FPGAs, where we have embedded FPGAs in all our servers in our environment. And we are now placing a lot of hope on quantum computing, on which we have done some announcements last week around a concept we call topological quantum computing, which enable you to create qubits in a very stable manner, so they are able to durate more and also to be able to have less interaction with the world outside. So there are a lot of different topics on which quantum computing could help ML, like speed-ups. But at the end of the day, if you look at the various machine learning methods, you have a list on the right where you could potentially accomplish quadratic or greater speed-ups. There is something which is not listed here, which is deep learning. And there is a very good reason for that, and I will stop there because it's the end of my time, which is basically, I would at least tell you why. So quantum computing is mostly based on linear algorithm. So everything within computing, quantum computing is made of linear algebra. Unfortunately, deep learning is based on some part of it on nonlinear transformation, which means that it is very hard to use quantum computing to do deep learning. But you can use, and this will be the end of my talk, quantum Boltzmann machine in order to do almost the same. So we believe that there is a very important field of research coming up around Boltzmann machine and quantum computing, because this is where we could accomplish very, very nice speed-ups. Thanks for your attention.